So yeah, so I was talking about the last round where there are only 3 steps, okay, instead of 4 steps. So that is the one change in the AES, okay. And in the decryption part, these rounds are happening in a reverse order, and those steps are also reversed. Okay, so we'll see now what are the steps which are happening. Okay, so I'll come to this algorithm or this figure a bit later. I'll just tell you what are those steps first. So substitute bytes, what happens is it is very similar to S boxes of DES. The only thing is S box and DES was very small. It was 4 by 16. Okay, and there are 8 such S boxes. Here there's only one S box which is of 16 by 16 matrix. Okay, what happens is whatever the matrix you are getting as an input, okay, what you have to do is you have to choose a byte. Let's say this is a first byte S00. Okay, it will have 2 nibbles, 4 bits, 4 bits. Okay, the first nibble will choose the row and the second nibble will choose the column. Okay, and whatever the data you have in this S box, you'll have to get that data and use that data in the same cell. Okay, so you have to work with the cell by cell, byte by byte. Okay, so this is the actual S box that you have to use in AES. Now again, this is a hard coded. No one knows how this S box has been generated, and that is why AES is still secure. Okay, and no one could break it till now. Okay, now how does this how to use this S box? Okay, consider that this is a input that you are getting. So let us say, I'm sorry, I'm going back few slides. Let us say you have the plain text and you have prepared the matrix. Okay, so all these 128 bits are put in a matrix 4 by 4. Okay, so once you have got this matrix, this is let us consider this is a plain text. Okay, so what is the first location? EA. What it says? EA. Okay, so maximum you can have the data is from 00 to FF, right? So all the entries are here, as this is a hexadecimal data. All the columns and all the rows are here. Okay, if the first byte or first cell is EA, what you'll have to do is, this is a left part is a row number and right part is a column number. So you'll have to refer the eth row, okay, and 8th column. So I'll go to eth row and which one is 8th column? So 8th column, I'll get 87. Okay, so I'm getting 87. I'll replace the first one by 87. So instead of EA, I'll substitute 87. Similarly, I'll go to the second byte. It says 04. I'll go to 0th row and go to 4th column. It says F2. I'll get F2 and I'll substitute F2 instead of 0. Okay, and this way I'll apply this logic to all the entries in the matrix, and the substitute byte, the first step in the round, will produce this data. Any doubts here, guys? Okay. Now, similarly, as there was a, this is the simple S box. there is an inverse S box. So at the time of last step or decryption step, you'll need the reverse box as well. Okay, so in that, if you provide this data, uh, you must get this as a output. So let's say this is a substitute box, this is the input and this is the output. This inverse S box will do the exact reverse thing. So for the inverse S box, this will be the input and this will be the output. Okay, for example, let us, I'm sorry if it is showing me the internet is unstable because I'm connected to mobile net. I hope I'm audible very clearly.
Yes, sir.
Yes, sir, you are. You are.
Okay, thank you. So now for the inverse S box, let us put this as a data 887. Okay, so I'll go to 8th row and I'll go to 7th column. So I should get EA, and that is my that is my input. Okay. Similarly, let us go to the example which we have not seen, 46 or C3. Let us go to C3. What I'll have to do is I'll have to refer inverse S box C3, C and 3. It gives me 33. It is 33. Okay. So these two boxes are related to each other. Okay, and they do the exact reverse operation. Okay, now the next step in the round is shift rows. Okay, so the first one is the substitute bytes. The second step in the round is shift rows. Okay, it's a very simple step. What you have to do is first you have to take the first row, okay, as it is. So if you have noticed, S0, I'm sorry, S00 is copied as it is, 01 is copied as it is, and so on. So first word or first row is kept as it is. Second row is shifted 1 byte left. It is not 1 bit shift left. It is a 1 byte rotate. So the complete byte will come at this location. Okay, and this byte is going at this location. Okay, so it is a circular shift. Okay, only the thing is it is not 1 bit left, it is 8 bit left, so 1 byte left. Okay, the third row will go 2 bytes left. The fourth row will go 3 bytes left, or you can say one byte right. 3 bytes left or 1 byte right are both operations are same. Okay, so if you have shifted 3 bytes left, let us say this you want to shift at 3 bytes left, S33. So it will come here, here, and here. So S33 is coming here. S32, 3 bytes left at 1 location, 2 location, and 3 location. So S32 is coming at this location. S32 is coming at this location. So it is similar to 1 byte shift right. Okay, so this shift rows transformation is doing all these things. Okay, shifting of rows. This is just the example. If you want, you can execute this. So the first row, it is the same row that we are getting at the at this one, at this step, first step. Okay, so we are working on this data. Okay, 87 F2 4D 97 will be copied as it is because it is a first row. EC 6E 4C 90, it will be shifted 1 byte left. So 6 is coming here and so on. So it is very simple to understand. You can just do it a bit later. The third step is mixing of columns. Now this step is a bit difficult to understand. But if you just notice it, you must be knowing the matrix multiplication. Okay, it's a very simple thing. This is a fixed matrix that you have to work on. Now, whatever the data you have got from the previous step, from the previous step, you have got this matrix. Okay, so this matrix you have to multiply with this data, this matrix. Okay, so what you'll have, if you remember matrix multiplication, if I'm multiplying this matrix 4 by 4, can I multiply 4 by 4 matrix with 4 by 4 matrix?
Yes, sir, we can.
How is it possible?
The number of columns of the first matrix must be equal to the number of rows in the second. So 4 and 4.
Right, right, correct. But here, just a bit tweak we have to apply in AES algorithm. What you have to do is you have to choose the first column. First column's size is 1 by 4. Is it correct? Is it, I'm sorry, 4 by 1. What is the size of first column? 4 by 1 or 1 by 4? So you apply the rows first or the column first? Let me see. It is the row by column. Okay. So the matrix size is 4 by 1. Okay. What you have to do is you have to choose the first column. Okay. And you have to multiply the first column with this matrix. Okay. So this column will be chosen from the data. Okay. And you will produce a, what will be the size of the multiplication? It will be again a single column which has 4 rows. Okay, whatever product that you are receiving or you are getting, that product will be kept as a first column in the output. Okay, or the new matrix that you are getting. Okay, so what you are doing, actually we are mixing up the number of bits with this matrix logic. Okay, so if you remember in DES, we are just changing the positions. First bit is going at third location, 40th location, and so on. So instead of this, we are multiplying this data with some fixed number, and then we are producing some data. Okay, whatever the data is there, we are getting this as a output. Okay. Now these are just the representation. What will happen here is it is just a multiplication you have to do. So S00 into 2 plus S10 plus S20 into sorry, plus S30 into 3. Okay, so that those things you are adding and all these things, right? So sorry guys, there's a lot of disturbance of network today. So have you understood this step? Mixed column transformation. So if you apply, and this is a inverse mixed column, while doing a decryption, instead of this matrix, you'll have to use this matrix. Okay, this is the inverse mixed column transformation.
So we can't see your screen.
Oh, I'm sorry. Very sorry. Just happened because of the. Okay. So yeah, I was talking about this inverse mixed column transformation at the time of decryption. this is the matrix that you have to follow instead of the previous one. So this one is the mixed column transformation, and this is the inverse mixed column transformation. So this is the matrix that you have to follow. Okay, the logic is same. You have to multiply this matrix with the original matrix. Okay, and the last step in the round is add round key. Okay, it's a very simple thing. Whatever the data you are getting, it has to be XORed with the original data. Okay, just you have to remember that you have to XOR the representation is given that the column is XORed with the column. Okay, if you do the other way around, I think you'll get the same output, but you can check that. If you apply the row by row XOR operation, what you are getting. If you apply the column by column, what you are getting. Let me just. No, you'll not get the same operation. I guess I'll have to do it manually, but you can check that. What you have to do is you have to XOR it by column. Okay, in this fourth step of the feastal function. Okay, so these are the 4 different steps that you have to follow. Okay, I think I should stop here. It's getting too much. Okay, guys. So these are the 4 steps that I wanted to tell you. I've already shared the PPT with you. What I suggest is you can go through these steps that I have explained you. Then if you have any queries, we can discuss it later. But I can stop here. I have explained you most of the AES part. But the things to note is AES is still secure.